our class today. Good morning, everyone. Uh, Yogi, can I
Yes,
share my
yes,
screen?
yes.
Okay, thank you. Okay, so good morning, everyone. Sorry. Okay, so today we are going to learn about that one data mining techniques. We start from classification. Okay, so classification is the text of data in data mining. Here in classification, we will have a set of attributes, usually like x, can be many x here, and then we will give this attribute set into a classification model. Then from this classification model, we can predict the class of this attribute set. Yeah, so the classification means that if we have a set of attribute input as the input, and then we give this input into the model, then we can get the output. What is the class label? Yeah, so this is the main purpose for classification. Okay, so here we have classification model. So how to develop the classification model? So basically, in classification, we will have training set, and of course, this training set, classification is for supervised. So it means that in our data we will have attributes, and in one of the attribute is the class of the data. Yeah, so this is supervised. So classification is for supervised. Here we have training set, or let's say this is our data. This is the historical data. Let's say this is historical data, or data on hand. Yes, so this is what the data that we have. From this data, we will develop one model, classification model. So it means that our model will learn from the data that we have. Okay, so after we have the model from the historical data, we will apply this model to predict a class of the new data. Okay, so this is like let's say this is the future data. It means that this future data, it has the same attributes. Of course, the attributes should be the same. Yeah, but then we are going to predict the class for each instance in this data set here. Yeah, so in classification, before we predict the class of the new data, we have to develop the model first. How to develop the model? We use the historical data that we have to learn and build the model. Okay, this is the
Dr. Vera,
yeah.
so this is like most likely this is like a logistic regression if that is yes, no. Is that correct? Can I say like that?
Oh yeah, but then the class can be two class, three class.
Oh yeah, yeah, yeah,
Can
yeah, yeah, yeah. That's a different. Yeah, that's a different. Okay, okay.
okay, okay, yeah. There are some. This one is the general approach. So we have historical data. From historical, we get the model, and then we apply this model to predict the new data. There are some techniques. Yeah, we have, for example, decision tree, we have neural network, we have rule-based, memory-based, super vector machine. all of these methods, the main principle is the same. So they will utilize the historical data to build the model and then use the model to predict the new data. Okay. Okay, and then this is one. No, no, not one. This is the examples of the classification test. For example, first, we are going to predict the tumor cells as a benign or malignant. So there are two different tumor cells. One is dangerous, one is not. It's not really dangerous, I think. Okay. And we also, for example, we can apply classification to classify the credit card transaction is legitimate or fraud. Okay, and for example, we also can classify the structure of protein, or we can categorize or classify the some stories as finance, weather, entertainment, and some others. Yeah, so all of these, of course, we can apply classification if in our data, the main purpose is we want to predict their class label, and we will have at based on the attribute set. Okay. In classification, we have confusion matrix. Confusion matrix is a matrix to measure the performance of classification result of the classification technique. Basically, we have accuracy and error rate. Accuracy is the number of correct prediction divided by total number of prediction. Error rate, inverse of accuracy, so this will be the number of wrong prediction divided by total number of prediction. For example, this is the confusion matrix of two classes. We have class 1 and class 0. So we have the actual class. Then we will compare with the predicted class. Of course, this confusion matrix can be applied to calculate the accuracy and error rate of our historical data. Means that we know already what is the actual class. So for example, this one in the this value is the number of data. Yeah, this one is number of data instance. Okay, for example, this is F11. It means that if the actual class is 1, this F11 is number of instance. If the actual class is 1 and the predicted class is also 1. F10 means that if the actual class is 1, but the predicted class is 0. So F11 is the correct answer. Yeah, because the actual class is 1, predicted class is 1. F10 is the wrong prediction because the actual class is 1 and the predicted class is 0. So this is the wrong answer. This one, F01, if the actual class is 0, but the predicted class is 1. So this is also the wrong answer. And this one, F00, actual class is 0 and predicted class is 0. So this is the right answer. It means that the accuracy will be F11 plus F00 divided by F11, F10, F01, F00. And for the error rate will be F10 plus F01 divided by all of the number of data. F10, F00. Like this. Yeah. If we have 3 classes or more, then we just have, for example, this is class 2 and this one will be class 2. Then we see which one is the correct answer. Okay. And now I will start with the basic one for the classification. This we use decision tree. Yeah, because decision tree, there are many classification techniques developed based on this decision tree. Yeah, so start from the basic one. So what is decision tree? In decision tree, Now let's say this is the tree. Yeah, we have the roots and the branch. Decision tree will use historical data, which has, of course, we already have the target. For example, this is the data. Let us say the data, the attributes, or they have the predictor, because we predict the target using outlook, temperature, humidity, and windy or not. Yeah, so we have four predictors to predict one target. So based on the outlook, temperature, humidity, or windy, we will predict if someone will playing golf or not. Okay, so this is the historical data, and then from this historical data, we will build the decision tree. Okay, after we build decision tree, we can use this to predict the class of the new data. For example, if the new data, the outlook is rainy, temperature is hot, humidity is high, and not windy, so will he or she playing golf or not? Yeah, to answer this, we can utilize this decision tree. Okay. Also for the second data. Yeah. Okay. Then let's see.
Dr. Vera, how
Yeah.
many
Yeah.
data for the I would say that for the testing? How will you divide the the data for the testing and the data for the constructing the I would say that the algorithm or constructing the based on the historical data, how you split that 80-20% or what?
Uh, uh, the- Later after this, I will show you how to evaluate and how to determine to divide into this training and testing. Yeah.
Okay, thank you.
Okay. We have decision tree, for example. Decision tree. This is the component of decision tree. For example, this one, the first one, of course, this is the root, and then this is the green one. This is the leaf or terminal nodes, and the blue one. This is the decision nodes. Yeah, so we have a root and leaf and also terminal nodes. Terminal nodes, a leaf can be terminal node if the leaves is the last one. So we don't make any more further branch of this leaf. Yeah, we don't have this. So this will be the last branch is the terminal. Sorry, the last leaf is the terminal nodes. Okay, the root, of course, the root is the first one here. It is the root. Yeah. Okay, and this is the terminal nodes, and this the blue one, this is in the middle. This is the decision node. Why is decision node? Because we will decide to split, the further splitting. Okay, so how to build decision tree? Okay, if we see the decision tree, uh, if you ask me like this is using decision tree for iris dataset. We know iris have four attributes. So if you ask me how to split this, yeah. So this is the problem of building the decision tree. First, there are many decision tree that can be constructed from a given attributes. For example, we have attribute 1, attribute 2, attribute 3. From three attributes, which one will be used as the root nodes, as the root here? Is it A1 or A2 or A3? There are many combinations of this. Okay, so this is the problem of building decision tree. We also have to find optimal if we have to find the optimal tree, the computational time will be very high, yeah, because the size of the tree is exponentially very high. Yeah, if we only have three attributes, maybe the combination will be let's say a this one will be a2, this one will be a2, a3, and quite simple because we only have 3 attributes. But if we have many attributes and all of these attribute is continue, then this we have so many combination of 3. Yeah, so it's quite difficult to find the optimal tree. That's why many algorithms they try to develop efficient algorithms to induce the reasonably accurate decision tree in a reasonable amount of time. So here, this is the key. We try, the decision tree algorithm basically they try to develop the suboptimal decision tree with reasonable amount of time. Yeah, because if we want to find the real optimal decision tree, the time will be very very high. Okay, so this is an example of algorithms to build decision tree. Okay, let's start from Hans algorithm. Why I choose Hans algorithm in this class? Because this algorithm, basically this is the uh, basic procedure used by many further algorithms. So this is a very basic ways, and many algorithms they use this algorithm and then modify. Yeah. Okay, let's say we have DT set of training records, or if I say training records, mean that this is the historical data that we have, which associated they are associated with the node T, and we have, for example, the data have C number of class. So if we have class 0 and 1, then we have Y1 and Y2 only. Yeah, so this is the number of class. Okay, first we see in one lives. Yeah. If all records in DT belongs to the same class, then T is the leaf node labeled FYT. Means that all data in this leaf, they are all belong to the same class. Okay. So this class label as node YT. Okay. And then if DT content records that belong to more than one class, it means that we have to divide these nodes, leaves into further. So if this, for example, this is belongs to Y0 and Y1, yeah, still mix. So we have to split this into smaller subset. So at the end, we will have all data in this leaf have the same class. Okay, I think I just start using example. So it will be more clear. Okay, I will use data about playing golf. So here we have for predictor. Yeah, this is the target. This is the predictor. First, we have to decide which one is the which one is the root. Okay, so for example, in DT, we try to using for default. Let's say a sum that in this is all the data belongs to this. Put all data, for example, on these leaves. Then we see we have how many data? 2, 3, 4, 5, 6, 7, 8, 9, 13 data. And then from 13 data, 9 of them, the target is yes. And 4 of them, the target is no. Yeah, this one, no, 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 no. We have 4 and 9 yes. So by default, we try to set at first, yeah, we try to set the class or the target here is belongs to the majority of the class. Majority is 9, so it belongs to yes. But then, according to this step, if more than the data belong to more than one class, we have to choose attributes and then divide into the new subset. So here, we know that here it still have many data here. I mean many class here, more than one class. So we have to choose an attribute. Let's say, for example, we choose Outlook. Can I choose temperature for the first attribute? Yes, we can. Yeah. So enhanced algorithm, this because this is very basic one, so it hasn't decide how to choose between all the attributes. Later I will tell you how to choose we choose better attributes. Yeah. So here we use the random attribute. Let's say I choose Outlook. Okay. So Outlook, we see Outlook have three different value. It has rainy, overcast, and sunny. So here I divide it into three subset. Yeah. Outlook, rainy, overcast, and sunny. Then we can predict if the outlook is rainy, what is the target? If the outlook is overcast, what is the target? If the outlook is sunny, what is the target? Okay. So after we divided this, so here means that we choose outlook as the attribute for, they call it attribute test condition. Yeah, so here, okay, we use outlook to divide the data into smaller subset into the next leaf. Okay, here we see. So this one, outlook rainy, in the color of green. Let's say how many data have outlook rainy? 1, 2, 3, 4, 5. So here we have 5 data which have rainy as the outlook. Okay, so after this we have this one, 2, 3, 4, 5. Okay, we see, and then we check the target of this 5 data. First data target no, second data no, rainy data no, uh, this one yes, the fourth data yes. So here, because we have how many yes, how many no, we have 1, 2, 3, 3 no, and 2 yes. Again, here we see from here, because the first majority class is no, so we can set default as play golf no. If the outlook is rainy, play golf is value is no. But then we still have to continue this list. Why? Because the data here, the class, they are still have more than one class. So here we have to continue branching these leaves. Okay. How about the overcast? Let's see the overcast. Overcast, so let's identify which data have the outlook overcast. This one, this one, this one. So there are four data here. And then let's see the class of this data. First overcast, yes. Yes, and then yes, yes, yes. So we have 4 yes and 0 no. Here, majority class is yes. Branching, let's see. In this list, there are 2 class. So we still have to continue this. Okay, any question until this part?
It's getting
No?
hard.
If you still cannot catch the idea, I can repeat this again. You
I
just
got it. I got the idea, but but it's getting
so
hard.
basic.
Yeah, yeah, really, really, it's getting hard. Yeah,
Yeah.
right. Let's ask other PhD. Dr. Young, it's getting hard, isn't it?
So we
Yes,
start
yes.
to really
Yeah.
really learn. Yeah.
Yeah.
The
Okay.
last the last 2 weeks is still theory. So now we
Yes.
start.
Now is really, really the the data mining.
Okay, yeah. So the main idea, just remember if the class is still mixed, then we still have to branching. If the class is not mixed, then we can stop. Okay, let's continue to branch. Okay, here I think we start from this part. Okay, so before this, we know that there are 5 data goes to this list. Yeah, because from the outlook, they have 5 data which has the rainy outlook. And then, because they are still mixed, sorry, I back to this again. Because they are still mixed, so what should we do is we have to determine, we have to choose another attributes to divide it into the next subset. So here we choose another attribute. Yeah, so every time we we evaluate one leaves and the class is still mixed, so we have to branching this leaves. How to branch? We have to choose the next attributes to divide it into the smaller subset. Okay, so let's say for example, to divide it into smaller subset here. For example, I choose temperature then as the next attribute. Okay, so let's see. Temperature. Oh, remember this one only the if only for the data which has rainy outlook. So other data, if the outlook is not rainy, for now for this branch, we can skip that first. Yeah, so we only focus on this 5 data. Okay, temperature. Let's see how many different value for temperature. We have hot, mild, and cool. So we have 3 branch: hot, mild, and cool. Okay, and then let's see the same ways. So start from hot. We identify which data or how many data which has outlook rainy, temperature hot. Okay, let's see. Rainy, hot. Okay, 1. Rainy, hot. 2. Rainy, mild, letter. Rainy, cool, letter. Rainy, mild, letter. So here only have 2 data. Okay, 1 and 2. Yeah, rainy, hot. Okay, rainy, hot. So we see how many yes, how many no. No, 0 yes and 2 no. Okay, so majority class is no, means that here the class is play golf is no. And should we do branch here? No need, because the class already the same class. Yeah. Okay, so we can stop because all records belongs to the same class, which is no. Okay, continue to mild. Okay, so the same way we identify the outlook is rainy, temperature is mild. Let's see. Rainy, mild 1, rainy, mild 2. Okay, so we have 2 data here. Okay, 2 data, how many yes, how many no? We have 1 no and 1 yes. So 1, 1. Okay, in this case, we can, for example, assume because the number of each class is the same, so you can choose both yes or no for the, let's say, temporary class. Yeah, here. And then because the class is still mixed, so we have to continue branching these leaves. Yeah. Okay, continue to cool. So for cool, outlook rainy and temperature cool. Rainy, cool. Rainy, cool here. One. Only one data. Only one data. And then the yes or no. One yes, zero no. Okay. Here majority class is yes. So the class is yes. And should we record? So should we continue branching? No need. We can stop because all records already in the same class, yeah, which is yes. Okay, so this one stop, uh, mild continue, cool stop. Okay, any questions?
Ah, it's clear.
Oh, okay.
Okay, yeah. So here don't forget, if we in this branch, we still have to see the previous branch. Make sure all the all criteria is met. Okay, we continue to branching the this one. Okay, so here because the mild temperature should be further branching, so we have to choose one criteria. For example, I choose humidity. Okay, humidity have high and normal value. So here I have high and normal. Okay, first from high, let's try to calculate and identify how many data belongs to these nodes. So here we have to find the data rainy, mild, high. Rainy, mild, high. Okay, only one. Okay, so here only one data. How many yes, how many no? Zero no. Zero yes, one no. So here the majority of the class is no. Okay, and we can stop this branching because the majority or all the data here belong to one class. Okay, how about the next one? This one, rainy, mild, and normal. Rainy, mild, and normal. Only one, yeah, here. So we have only one here. And the class, we see one yes, zero no. So the majority of the class is yes. And we don't need to branching again because all the data here belongs to one class already. Okay, so this branch we can stop. It means that for this area we can stop. Okay, with this one stop already, we can continue to this one, sunny part. Okay, let's start from sunny. In sunny, let's say because sunny, this one sunny have a mixed class, yeah. So I choose temperature as the next attribute. Sorry, I choose temperature as the next attributes. Okay. Here we identify the outlook sunny. Outlook sunny 1, 2, 3, 4. Yeah, we have 4 data here. And then see the temperatures. We have mild and cool. Okay. Okay, cool and mild and cool. Okay, so here mild, cool. Okay. Here for cool, for example, start from cool. How many data? Sunny, cool. Let's see. Sunny, cool. One. Sunny, cool. Two. There are two data. Two instance here. And how many yes, how many no? We have one yes, one no. Okay. So here we have to further branch this list. Yeah, so we have to continue. How about mild? Sunny, mild. Sunny, mild 1, sunny, mild 2. We have two data and both of them, the class is yes. Okay, so the majority class is yes, and it's already in the same class, so we can stop branching these leaves. Okay, we just continue this one. Okay, here for cool until this part, yeah, we have to choose one attribute, and we have two attributes remaining, humidity and windy. Here uh, I try to identify sunny, cool. Let's see, sunny, cool, we have two. Why I don't choose humidity as the next attribute to divide the data? Because if you see here, uh, all of this data, I mean, we have two data, yeah, 1 and 2. All of them, humidity is normal, the same humidity. So if we use humidity here, it will be no no use, yeah, no effect, because all of them humidity is the same. So we have to use another attributes. Okay, so in this case, I choose the last attribute, windy. Okay, yeah, I use windy because they have different value of windy. Okay, windy, they have false and true. True, false. Okay, let's see. So here we see uh, which one is sunny, cool, and the windy is true. Sunny, cool, true, or this one. Okay, so we have one data here, and the class is no. 0 yes, 1 no. Here, so the class here is no. And we can stop this because all data already in the same class. Uh, then the next branch, sunny, cool, and false. Sunny, cool, false. This one, only one data. Number of yes is 1, 0. So the class here is yes. And because of this data already in the same class, so we can stop these two branches. Okay, so finish. This is the final tree of this algorithm. Okay. And
I have a question.
yeah,
Why again?
yeah,
Why not how you say that?
humidity.
Humidity again. That one I still don't
Okay,
cannot get it.
so let's see if we here we choose to humidity. For example, after temperature, and then we use this one, humidity. Okay, let's see. Uh, Humidity here only one value, normal. So we cannot, if we choose humidity as the attribute, only one branch here, normal. And then the result is still the same. We have two data, which here has yes 1, no 1. Still cannot divide the data into different class.
I got it. Okay.
Yeah, yeah, because this is the same value. If, for example, one normal, one high, this one, if this one is high, okay, we can use humidity. Yeah. Okay, so after we have complete tree like this, what we will do is we can use this tree to predict the new data. Okay, for example, oh, no example. Okay, for example, we have the new data and then the outlook, for example, the outlook is rainy and the temperature is cool and the humidity is high, for example, and windy is true. So let's see. Outlook is rainy. Nice, different color. Outlook is rainy, so it goes to this area. And the temperature is cool. This one. Uh, Class is yes. So for this new data, the class is yes. Okay. try another one. If the outlook is overcast, then we have hot, high, true, and with what is the class. So the outlook is overcast. Here, play golf is yes. Okay. Yeah. So this is how to read the decision tree. Yeah. If we want to read the decision tree and to predict the class here, okay, we have to go through each branch. For example, like this is the rainy. Oh, rainy is go to this part. And what is the temperature? Temperature is cool. Oh, so go this. How if the temperature is mild? So check we go to this area. And then if the humidity is normal, oh, we go to this area. This. Yeah, so this is the way we read the decision tree. Yeah, for example, like this. This is the decision tree for iris. Okay. First, we have to see what is the petal length. So petal length, if the petal length is less than 2.45, then goes to this. This is the true, means that true belongs to this. Uh, what? This is the condition. Okay. And if false, it means that the petal length is greater than 2.45, then go to this area. And then see the next attributes. And then which one? Yeah, if this is the last or the terminal nodes, so we get the class already, just like this. Okay, any question? Yeah.
Dr. Perez, sorry, can you please repeat this part?
Okay, so here for this tree, you do you understand how to read the result?
Yeah, this one, yes. But
This one
the
is okay. Okay,
yes.
some value attributes, they are continuous. So this is another way to uh, to present the decision tree. For example, this is for iris. So here, this is the root. In the root, they use petal length as the attribute. Okay, so they make one condition: the petal length less than 2.45. Then, if it is true, then we go to the left branch. If it is false, then we go to the right branch. Okay. If you ask me how they get this number, later I will tell you how to get this. Okay.
But reading like this one is actually very complicated. You think?
Yeah,
I mean,
this is more
yeah, yeah,
complicated
yeah, yeah, more
because it,
complicated.
yeah, because this has a different value. I think after I give more explanation, we will come back to here. Okay, because this is
Okay,
the
So,
because this is new.
okay.
hello, Doc Sarah.
Yeah.
Is the genie word located on this slide similar to Gini index from Operation Research?
What is Gini from Operation Research?
The one we use to separate, the one we actually use to identify, for example, the petal length.
Okay. I have one slide for Gini. Maybe I will show you later. Okay.
Okay, thank you.
Okay. Welcome. Okay, so here there are two main issues in developing the decision tree. First, I think we know that we have to specify what is the test condition. Okay, and then how to measure the for evaluating the goodness of the test condition. Yeah, so here, let's see, I just choose randomly. First I choose outlook, and then I choose temperature, and then I choose humidity. But is it the good sequence? I don't know. Yeah, because this is still I choose randomly. So here, for the filter algorithm, they try to evaluate our attributes in for to separate the data. Yeah, so we have the measure for evaluating the goodness of test condition. Okay. Beside this, how should the training records be split? We also have another problem. How should the splitting procedure stop? Yeah, we can have stop splitting if all records belong to the same class, like what we have done here. But this condition, we can do like this. We just stop after all data belongs to one class, because the data is not really complex. Let's see, the number of data is also only 13. Yeah, so this is the simple case. But if the case is already very complex, sometimes it's very difficult to get like this condition, stop after all data belongs to the one class. So sometimes we have to do what we call it early termination. Okay, so let's see. First, how to specify the test condition. Specify the test condition, it will also depend on the attribute types. In our case, we have categorical data. Yeah, but how if the data is continuous? Okay, so now let's see different split ways for different attributes type. Okay, for example, we have binary attributes. For example, if the attribute is only binary, let's see, we have yes or no. Like in our data, in the windy, for example, windy only have value false and true. Means that this is the binary data. Okay, so for binary data, we can simply just divide it into two branches. For example, this is the card type. They have two different value, non-family and family. So they can separate into two. In our data, for example, we have windy. We can just false and true. Easy. Right? This is a very simple one. But how if we have a normal attribute have many value? For example, card types. They have three value. So we have card types, we have family, we have sports, we have luxury. Yeah, so have many different value. Or in our data, for example, we have outlook. Outlook, we have rainy, we have overcast, and we have sunny. Yeah, we have three different value. So in this way, so if this is the nominal attributes, remember nominal means that for different value, they have the same degree. Or we cannot say family is better than sport, sport is better than luxury. So all of these value have the same level. Yeah, this is the nominal attributes. So in this case, we can divide it in, we can use multi-way split. Multi-way split means that each value has different branch. Yeah. If we have 5, then we have 5 like this. If we have 6, then we have 6 branches. Yeah, multi-way split. Each of value, different value have different branch. Or we can use binary split. Binary splits means that we like this, for example, sport and luxury into one branch, family into another one. Or we can divide it like this, family, luxury into one, sport, it can be one, or maybe family, and sport into one, and here is luxury. Okay, yeah, there are many different ways to divide into binary. So basically, we divide it into two groups and have only two branches. Yeah. Okay. For ordinal attributes, basically we can also use multi-way and binary split. For multi-way, for example, we have search size, small, medium, large, extra large. Yes, if we use multi-way, then this is the multi-way. Okay, so each of value have different branch. Okay, but if we use binary split, it means that we divided value into two subset, similar like this, divided into two subset. But what is different? Because the ordinal attributes, it has the different level for each value. Let's say, for example, we have small. Of course, small is smaller than medium. Medium is smaller than large. Large is smaller than extra large. Okay, so if we divided them into two subsets, we have to consider the level. For example, small and medium, because it's closer, so we can put in one subset, large and extra large. Okay, or small alone, medium, large, and extra large is also alone, have another subset. Or maybe small, medium, large in one subset, and another subset is extra large, for example. Yeah. So here means that we consider their order, small, medium, large, and extra large. We cannot do like this because, let's see, small and large, medium and extra large, the order, different. Yeah, they violate the order, small and large. So like this, small and large, medium and extra large. Yeah, so this is wrong way to divide it ordinal value into two binary split. Okay. Nah, another complex splitting ways is if we have continuous attributes. So if you see in our example here, we don't have like this, we don't have continuous. This all categorical. Yeah, outlook, we have rainy, overcast, sunny, temperature, we have hot, mild, cold, humidity, we have high and normal, windy, we have false and true. There's no attribute, there's no continuous attributes. So it's quite easy to make the decision tree. But how if we have continuous value? How to divide it them into, we have continue 100 until 0 until 10, for example. Let's just say 10. Value can be 2.5, 2.01, because this is continue attributes. So how to divide it like this? In which value we have to separate this? Is it less than 5, or this is 5? And how to determine this threshold? Or can we divide it into multi-way split? Yeah, okay. This for continuous attribute is more challenging. Okay, so there are different ways to handling this continuous attribute. First, we can use discretization. So we transform our data, our continuous attribute, into a discrete value. Yeah. So for example, this value we change into the discretization. Okay, discretization. I think in the last week we discussed about this already. There are many ways to do discretization of the data. Okay, if we already have discretization, then we can see, we can use, like, for example, using this like ordinal attributes. Okay, we also can use like binary decision. So if we use discretization, we can do multi-way split. But for binary decision, then we will only have a binary split. Yeah, only like this. Okay. But again, how to determine the threshold? The threshold, because our value is continuous. Okay. Okay. If we consider all possible splits and find the best cut, of course we can do this, but it can be more computer expensive. The computational time will be very, very high. You can imagine like we have only 0 to 10, and accuracy is one number after the decimal. So we have so many different value we can choose, we can use as the threshold. Okay. For example, like this, annual income, for example, how to choose 80Ks. If or this one, it use multi-way split. Yeah. Okay. So how to determine the best split? For example, like this. Uh, how to determine the best split is not only happen for the continuous attributes, but it's also happen in many different in 3 other different attributes. For the for the binary, of course it only have one way, yeah, using binary split. But for the multi ways, yeah, you can see that there are many different ways to do this. Okay, so here, to determine the best split, we can choose which one split which can give us the more or the purer class distribution, or we can choose nodes which has the less impurity. So we choose the pure one. What is the impurity? For example, we have like this. In one leaves, there are 2 class, 0 and 1. And let's say there are 10 data here. 5 belongs to class 0. So here, because it has the same number for different class, so so the degree of impurity considered as high. Example for the low degree of impurity. Here we have 10 data, but we have 9 data belongs to the class 0, and only 1 data belong to the class 1. So compare these two. This one, they have lower degree of impurity. What is the perfect degree for impurity? We have class 0, 10, class 1, 0. This is the best impurity. Yeah, because the
Dr.
class
Vera,
is pure.
I still don't get it. What is the high impurity in here? What does that mean?
Okay, if we come back to our example, let's see. For example, this one. Yeah, we have 2 data, and then we have one of them belong to class 1. One of them belong to yes, one of them belong to no. Okay, compared to this one, we have 2 data. 2 of them belongs to class yes, 0 belong to class no. So which one of them do you think is the best one?
I think the one without the that one. Yes, the
This
mild
one,
one.
right?
Yes, that one.
Yeah.
Yeah.
Why? Because the in data in this leaf, they belongs to one class. It
Yes,
means
only
that
belong to one
it's
class. Yeah.
pure. Pure belong to one class. All data belong to one class. Okay. Or the impurity
100.
is
100.
zero.
Oh, impurity is zero.
Impurity
Oh,
zero. Pure is 100%. Okay. Uh,
okay.
Okay. But for this one, we cannot say, oh, so if I ask you, oh, if the outlook is sunny, temperature is cool, will they play golf or not? They can yes, they can no, right? It's difficult to answer because the class here, the impurity is very high, or we cannot say certainly whether they will go to play golf or not. Yeah, because like 50-50, 50% yes, 50% no. Okay. Yeah. Oops. Okay. Yeah. This is for example. Uh, let's say this is the number of data. Yes, no. For example, yes, no. Okay. So if we have this one, and then we say, oh, if the data belongs to this class, we can for sure we 100% sure that, oh, they will belong to the yes, they will play golf or belong to class 0. If in this case, yeah, 9 compare by 1, so oh, we can, for example, yeah, we can sure 90% that they will play golf because this is yes no, for example. But yeah, 90%, like we can say 90%. But in this
I
case,
see. So you mean impurity in here is actually that splitting that one, right? It's not the yes, no, the higher the yes, right? I mean the splitting of
yes,
the probability. Okay, okay, I get it.
yeah, splitting of them. Okay, if all data in one leaves belongs to one class, then the impurity will be 0. Yeah, the best one. Okay. Okay, so here, nah, this one, I think one of you asked about Gini. Okay, so Gini basically here we use Gini as the measurement for the impurity, to evaluate the impurity of each nodes. We have 3, for example, we have Gini, entropy, and misclassification error. Actually, they have many others evaluation measurements, but this is the basic one. We have Gini, entropy, misclassification error. Okay. Okay, so basic procedure to find the best split. First, we compute impurity before splitting. So for example, we have this 10 data here. Belongs to class 0, class 1, for example. 5, 5. This is for example. This is means that the before splitting. Okay, and then after splitting, let's say we split into 2 class. Here, we calculate after splitting. From here, we have, let's say, M1. From the second branch, we have M2. Then we have here M. And then we can calculate what we call it gain. Gain is P minus M. P minus M. Okay. So here, this is the one way we can get gain. Okay. One way to split. We have another splitting. The same data, 10, class 0 is 5, class 1 is 5, but we use different splitting. For example, here we use multi-way splitting. 1, 2, 3. This is the P, means that impurity before splitting. And then here we have M1, M2, M3, and from all of these 3, we have M, and then we have gain, P minus M. Means that for this way, multi-way split, we have another gain. So if you ask which one between first way and second way, which one is the best one, we compare the gain here. Gain 1, compare gain 2. Which one is the highest one? If, for example, oh, gain 2 have the highest number, for example, gain 2 have 10, for example, gain 1 is 5. Also, we choose this way. So means that this 10 data, we can use multi-way split so we can get better purity or impurity. Okay. Let's see for example. Sorry, any question after from at this part?
I think I want to see the case, Dr. Farah. The case,
okay.
yeah, the case, yeah, because my brain is kind of like, I need the case.
Yeah. Please give me 1 minute. I want to drink.
How is that, Artin Ong? It's so.
I feel like I need to see the case also.
Yeah, I know. You see, right? let's ask the Thailand students. Taf, is it okay, Taf?
Hello, sir.
If you have questions,
I'm
just ask.
I'm very confused, sir.
Confused.
Okay. Let's see. Okay, this is the example. Oh, this is the same way I just tell you. Okay, so before splitting, this is the data before splitting. And then we have, for example, in our case, we have what humidity. In our previous example, humidity, outlook, yeah, outlook, humidity, temperature, and windy. Before, I just choose randomly, or I choose outlook as the first one, for example. And then I choose humidity, for example. So here, how to improve our previous example. So now, for example, instead of choose randomly, I try to compare how if at the first time I choose outlook as the first splitting condition, and then I compare with humidity, for example. Yes, and then after we separate into outlook, and sorry, before that we calculate the P, and after we do splitting we compare. Okay, let me give you example. Wait, I prepare one slide, for example. Oops. Okay. So this is our example, our previous example. For the first example, we choose outlook. Okay. Oh, sorry. Maybe before outlook, we have to calculate the. We have to put the data first. Before do the first splitting, we have to calculate how many yes, how many no. Yes, no, for example. Yes, we have 1, 2, 9, and no, we have 4. Okay, this one. Okay, let's see from this one, we calculate the P using a P can be calculated using Gini, using entropy, or misclassification error. We can choose. Okay, and then this is the first way. The first way for splitting, I use outlook. So then I use, for example, outlook. In outlook, let's say I use I use multi-way outlook, for example. Multi-way outlook. So I have 1, 2, 3. Rainy, overcast, and sunny. Okay, and then we calculate the class here. For Outlook Rainy, how many yes, how many no? Rainy, yes, let's see, no, 1, 2, 3, 3 no, and yes is 1, 2. Okay, like this. And how about overcast? How many yes, how many no? Rainy, sorry, overcast. Yes, 1, 2, 3, 4. 4, 0. Sunny. Sunny, how many yes, how many no? Yeah, sunny. 1, 2, 3. 3 yes and 1 no. Okay, so here we have to calculate M1, M2, M3. From this we can calculate M. Okay, maybe I will choose, for example, we choose Gini. Later if we choose Gini to calculate M, P and M. Okay, give you example first how to calculate Gini. Let's say, for example, I choose Gini to calculate what is P, what is M, to calculate gain. Okay, how to calculate Gini? This is the formula for Gini. Okay, so here, for example, I think, okay, this one. This is the formula for Gini. So for example, we have C1 means that the class 1, number of data in class 1 is 0, number of data in class 2 is 6. Okay, so Gini, so each of them will have their own Gini. Okay, so here we have PC, probability of class 1. 0 means number of data here, 0, class belongs to class 1 is 0, divided by total data, 6, so 0 here. PC2, so probability of PC2 means that number of data here divided by total data, 6 divided by 6 equals to 1. So the Gini index is 1 minus PC1 square minus PC2 square. So it will be 1 minus 0 minus 1. So the Gini for this value, for this node, for this leaf, the Gini is 0. How about this? This is a second leaf, for example. In this leaf, number of data in class 1, they are 1. There's 1 data. And there are 5 data belongs to the class 2. Okay, so probability of class 1 is 1. 1 is from here, divided by 6. 6 is the total data. Yeah, 6 is the total data here. Probability of class 2, number of data belongs to class 2, this one, divided by total data, 6. Okay, so the Gini index, this one, is 1 minus PC1 square, this one, 1 over 6, minus PC2 square, this one. So it equals to 0.278. So the Gini value for this leaf is 0.278. Okay. The third nodes, for another example, we have 2 data belongs to class 1 and we have 4 data belongs to class 2. Okay, so probability of C1, PC1, 2 here divided by 6. PC2 is 4 divided by 6. So the Gini value for these leaves is 1 minus PC1 square minus PC2 square will equal to 0,444. Okay, so this is the way we calculate Gini. Okay, if we only compare between leaf 1, leaf 2, leaf 3, which one is the better one?
Leaf 3.
This
For
one,
me, yeah. For me,
the first one.
the first one, yeah, of course, it is zero,
Yeah,
right?
the
It's
first one.
obvious, yeah.
Yeah.
I
Okay.
thought the one with the higher value.
The
No.
lower value, because okay, Gini is the impurity, how impure this class. So for Gini, we choose the lower value. Okay, but if we calculate the splitting to choose which split is the better one, like this, we use gain. Okay, gain uh, gain is because the gain is the how big purity of the class, so we choose the highest one. That's for the gain. Okay, but for Gini is the small one. Gain is the highest one. Okay, so we back to our example. Where is our example? Okay, here, this one. Here we calculate Gini for this. So here we calculate Gini. Okay, Gini here. Wait, because on the right side I will use that for the second way of splitting. Okay.
Dr. Farah, can I
Yeah.
just clarify?
Yeah.
So for Gini is one way of computing P, and we have to get the lowest value because it measures the impurity. But for the leaves, we have to we have to consider the highest value
No.
for the gain.
Gain calculate splitting. Gain is to evaluate a splitting way. Okay. Here. So here gain is gain P minus M. P is the Gini of the parents. M is the Gini after the splitting. Equal gains. So gain is P minus M. So gain is used to find the best splitting, whether we are going to split in binary or, for example, multi-ways, or if we want to use attribute A or attribute B. So we use gain. But if we only want to compare impurity between nodes, so here, nodes impurity measures by Gini.
Thank you, Dr. Farah.
Yeah. Okay. So nodes impurity using Gini or entropy or misclassification. But if we want to find the best split means how we split the data. Then we use gain. Okay. So if we use for the gain, we choose the highest value. But for Gini, we use the lower value. Okay. Maybe I will write table like this. Between Gini and gain. Okay. Gini to measures the nodes. gain to measure the splitting. Gini, we choose the lower one. Gain, we choose the higher one. Okay?
Yeah, it's clear already. Thank you, Dr. Fer.
Okay, you're welcome. Okay, so which one is okay here? M1, M2, M3, we will calculate their impurity, each of them, using Gini. For each node, we will calculate their impurity. Yeah, so first node here, the parent nodes. P, the Gini, we use Gini. So it will be 1 minus class, yes, 9 over 13 square minus class no 4 per 13 square. Okay, this is only the parent. Okay, how about M1? M1 Gini. 1 minus this one for yes, class yes, 2 per 5 2 over 5 square minus class 3 3 over 5 square. Okay, and we have M2 Gini 1 minus 4 over 4 square minus 0 4 square. And we also have M3 Gini. We have 1, this one, 3 over 4 square minus 1 over 4 square. Okay, we calculate this. Let me, wait, I think I will change my share screen so you can also see my Excel. Screen 1. Okay. We calculate Gini first for each node. Okay, we have our P here. Okay, sorry. 9, 13, sorry, 9, 13, 4, 13. Sorry.
I think I'm the only one who can understand that, right?
Oh my God. Okay. Let's see. This is should be 9 over 13. The next one, 4 over 13. Okay. So the Gini, this is the Gini, is 1. Oops. 1 minus this one square plus, oops, this one square. Okay. This is the probability of yes. This one probability of no. Okay. Oops. Why this? Okay. Okay. And M2. M2 is 40. So this is 4 divided by 4. This one 4 divided by 0. Sorry, 0 divided by 4. this. How about M3? M3 is 3 and 1. 3, 4, 1, 1, 4. Okay, so here, this is the Gini value for each leaf. Okay, so Gini is for leaf, for each leaf. Okay, so this one we have 0.61615, this one 1.2, this one 0, this one 0.5. Okay, 2, 5, 3, 5, 2, 2. Okay. Okay, then how to combine M1, M2, M3 into M. So this one. Okay, we call it a weighting partition. So this in our case, we have node 1, node 2. Each of them has Gini. For example, this is Gini 1, Gini 2. And how to combine into 1 for this, all of these. We will see the number of data. So let's see this one. In node 1, how many data compare with the total data in the parents? So in our case, let's see. They have 5 data. Oops, they have 5 data here. They have 4 data here. They have 4 data here. So the M value for this splitting M is 5 over total is 13. Oops, I cannot write there. Maybe I write here. M 5 per 13 divided by, times M1 plus second notes 4 per over 13 times M2 plus this one 4 over 13 times M3. So this one will be 5, 13 times 1.2 plus 4 over 13 times 0 plus 4 over 13 times 0.5. So this will be the M will be equal to is this?
Hello, Doc Farah.
Yeah.
I'm sorry, I think there is a problem with Gini formula on the Excel.
Sorry, what?
It was placed as an addition,
I think so. Yes.
but it should
Can you
be
check?
in subtraction.
Excel.
Oh, sorry. Yeah.
Yeah, see? Yeah. Yeah,
Oh,
should be.
this one. Oh.
Yeah, should be.
Thank
Yeah.
you. Okay, 0.480 and 0.375. That's why I confused why this value is more than 1. Thank you. So this is also wrong. Okay. 042 0 048 00375. Okay, this one will be 480 and 37. Okay, so this one 413 413 513. Okay, we times this 0.3. Okay, so the gain and the P here is 0.4 2. So gain for this splitting is P minus M, 0.4 minus 0.3 for 2. Sorry. So it's equal to 0.12. This is gain for this way of splitting. Okay, how if I have another way to split this data? For example, I choose temperatures as the attributes. Oops. So, for example, this is the parents, the original data still have, maybe I use different color. Okay. So we have yes equal to 9, no equal to 4 at the beginning. Okay. And then I use temperatures to split the data. So here I have hot, mild, and cold. Hot, mild, and cold. For temperature hot, so we see temperature hot, how many no, or how many yes, how many no. We have yes 1, yes 2, so we have 2 yes and 1 no. Okay, okay, here. How about for mild? So mild, we also calculate how many yes and how many no. 1 yes, 2 yes. So we have 2 yes and no, 1, only 1. Sorry, mild yes. 1, 2, 3, 4. 4 and 1. Mild no is only 1. Okay, 1, 2, 3. Okay, and for cool, we calculate yes, we calculate no. Cool, let's see. Cool yes. 1, 2, 3, 3. Yes. How many no? Cool no. 1. Only 1. Okay. So number of data here is 3, 5, 4. I think yeah. Okay. Okay. So here we also calculate M1, M2, M3. For P, the same because the same parents, right? P is value is 0.42. We just calculate here. So we calculate M1, Gini for M1. Here we have 1 minus 2 per 3, 2 over 3 square minus 1 over 3 square. For M2, we have 1 minus 4 over 5 square minus 1 over 5 square. We have M3, 1 minus 3 over 4 square minus 1 over 4 square. Okay, let's calculate Gini. This one we have 2313. 2313. Second one we have 4. Okay. Okay, so this is the Gini. 0.44 3233 32 0.33. So with the same value, we can the same ways, the same formula, we can calculate M. So M here is 3 over 13.
Oh, Dr. Vera?
Yeah.
Sorry. 1 over 4 for M3.
1/4, yeah.
In the Excel, I think it was 1/3.
Oh yeah, sorry.
Okay.
75. 0375. Okay, thank you. 313, 513. This one 032 plus 413 07375. So total M is 384. M is 3847. Okay, so here the gain for this second splitting is 0.42 minus 0.384. So it will be equal to what is this one minus this one? 0.04. 0.04. Okay, so we see this. The first splitting way, if we use Outlook as the attributes, we have gain 0.12.
The first one.
The first one, yeah, this one is the better one because, better one because it has a higher gain. Okay, so this is one way to find out which one, how to split our data. This is only one step. So if we back to our tree in our example, there is our tree like this. This is the final tree. That one is only the first way. So okay, we use Outlook for the first splitting. If we want to choose, for example, this one for the rainy. After rainy, we have three attributes. We have temperature, humidity, and windy. Which one we are going to use for this? We will use the same way. So here we choose maybe temperature. We split and calculate the gain, and then we compare if we use humidity, compare if we use windy, for example. Okay, so do you get the idea about gain?
Yes, I got it. For me, I got it.
How about the other students? Do you get the idea?
Yes, Dr. Fair.
Okay, so you also can use gain to compare. For example, we have Outlook. Still use Outlook, but for Outlook one, we use multi-way split. We have a rainy, overcast, and sunny. Or we can make it into binary split. Still Outlook, but we choose, for example, rainy, overcast, and sunny. So here we can calculate the gain. We can calculate gain and compare which one is the better one. Okay, so you can imagine now how many Gini or how many gain we have to calculate if we want to get the best tree. Yeah, it will be very, very complicated. We can do it actually, but the computational time will be very long because it's too many combinations we have to calculate. Yeah. Okay. Okay, this we calculate Gini. This one. This is what we just do it. Yeah, so we can use. Oh, you also can use. Besides Gini, you also can use entropy or misclassification error. Yeah, to replace the Gini. But to calculate the gain, still the same. Gain still P minus M. Yeah, but to what is P, what is M, you can use Gini, you can use entropy, you can use misclassification error, or there are others not impurity measurements. Okay. Okay, any questions until this
Which
part?
one you need to show, Dr. Farah, for the paper? Because I think it's kind of quite redundant if we show two. I mean, the genie and the gain, for example. You
Mhm.
you show both, or
The most common way they use Gini still.
yeah, right? Still only genie. That's enough, right? Yeah.
Yeah, yeah,
Okay.
it's enough. You can choose.
Okay.
Okay. Okay. So let's continue. So you know already what is gain, what is Gini. We can use that to find the best tree. Although it's very difficult. Okay. And okay, here if we have categorical attributes, we can use both multi-ways, we can use both like this. Yeah, we choose binary and we calculate the Gini, also we calculate the gain. Which one is the better one? Okay, yeah, so this one we can choose which one is the best one. Uh, Biggest problem is if we have continuous attributes, this one. So it's very difficult for not difficult actually the way to find out the way to evaluate is the same, but because of this is continuous, we have so many different combination for split the data. Okay, so for continuous, this one is for example, we have annual income. Is it the good way to split the data based on the annual income 80? Where I can get the 80? Okay, so this one. Okay, uh, this one example. If we want to use, if we want to find the best splitting for continuous attributes. Okay, so uh, this is the you can I think you can read this by yourself. I just continue to the example. Okay, so first what we do is we sort the attributes on the value. So here, let's see, we have this value for the annual income. Okay, so the first thing is we sort this value. Okay, this. For example, we have 60, 70, 75 until 220. Okay, this is the sorted value. And then linearly scan this value each time updating the count metric and compute Gini index. It means that we have to choose a splitting index. Okay, so first I think we check the data first. If 60, the class is no, for example. 70, class is no. 75, no. 85, yes. And for the next. Okay. And then for each couple of value, for example, this is between 60 and 70. The middle part, we can choose 65, for example. Oh, sorry. Before 60, we have 55. Can you use 62, for example? Yeah, you also can use that. Yeah, but this one for simplification, I just use a middle value between two value. So 60, 70, the middle part or splitting part is 65. 60 to 65, 70 and 75. 72 should be 72.5, yeah, if we want to make it more accurate. This one 80, for example. This one 87. This one 92 until this. Yeah, this one 172 and after that 230, 230. Okay. Then for each of them, ideally for each of them, we have to calculate the Gini. So means that let's see, for example, if we use this one means that you can imagine that the annual income, this one, if it is less than 55 and then higher than 55. So how many yes, how many no? We calculate this. And this part, how many yes, how many no? Okay. Again, for this part, the second one. This is the first one, this is the second one. For the second one, we also do the same thing. So the annual income, if the annual income is less than 65 and greater than 65. How many yes, how many no? How many yes, how many no? This one also, the third one, until all of them. And then we calculate each of them, we calculate the gain, or we choose the split position that gives a less or the smallest Gini index. Okay, this is the, if we want to try one by one for each of them. But we also can see, for example, let's see from the class. The first no, no, no. And then this one start to be different. After this one, yeah, in this part, after no, it start to be different. So we can try from this first. Okay, so we use focus on 80. If we want to save some time, yeah, we don't need to, we prefer to choose only one of them if we don't want to calculate all of them because it takes so much time. So we choose maybe several of them. So we choose some of them, and if you want to choose, try to choose maybe start from the first splitting value. For example, no, 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 and then different is yes. So we choose from this part. Okay, so the fourth one we calculate, and then the next also we calculate. For example, this one. We use 80. So if we use 80 for annual income, if it is less than 80, then they found out there are 0 yes and 3 no. And higher than 80, it has 3 yes and 4 no. Okay, and the Gini for each this is this one, 0, 3, 4, 3. Okay, then we start to calculate the next one, this one. Okay, we calculate one by one all of them. Okay, and we choose the smallest Gini. And we found that, oh, the smallest one is 0.3. And so this one is the best splitting value for annual income. So the best one, annual income should be less than 97 and greater than greater than 97. Okay, so the threshold is 97. Okay, so this is if we calculate manually. But don't worry, because right now already some program, or in Python they have some package to find out this. Yeah, so don't worry. But at least when you choose the package, you know what happened inside the package. Yeah, so this is the idea inside the package. Okay, so basically this is what we do for continuous attributes. Okay, any question? No?
Dr. Farah.
Yeah.
So for this one, it's fine just to determine the Gini, not the gain anymore.
For this, you can compare the Gini because we don't compare with the parent. This one we don't compare with the parent. We just compare this one, Gini of each nodes, average Gini of each nodes. Because for this, we only want to find out the threshold. Okay. But if you want to compare the gain, it's also okay, no problem. Okay. Okay, I continue. So besides Gini, you also can use entropy. This is the way to calculate the entropy. So the entropy, it used a logarithm. Okay, for example, like this, we have, I think this is the same value, but before we use Gini, now we use entropy. So for entropy, we still use the probability of each class, for example, like this. Okay, and then to calculate the entropy is minus uh, this this is the PC1. Maybe I should write like this, minus PC1 log times log PC1. Oops, like this, minus PC2 log PC2. Okay, so it's like this. Yeah, 0, this one is PC1, and this is PC1, this one PC2, PC2, so equals to 0. For this also, like this. Yeah, okay. Okay, this is the same. So this is for if we calculate the gain, if we use entropy as instead of Gini. Okay. Steam, still the same. We maximize the gain. Okay. Okay. We continue to evaluate some problems with decision tree. Okay. First, a problem with large number of partitions. Okay. So usually multi-way partition will give us a better gain. Okay. But we also have to be careful. For example, like this, customer ID. Of course, customer ID, every instance have different ID. So we don't need to use this as the splitting one, as the attribute for the splitting. Okay. Or maybe some value has too many, some attributes have too many different value. Yeah, so sometimes it will like this. Yeah, it will not give you any information because each of the instance have a distinct value. Yeah, so some solutions, for example, CART is one decision tree algorithm. It prefer using binary split. So for example, like this, for CART type, instead of using multi-way, the CART prefer using binary. For example, family sport and luxury, for example. Yeah, they always use binary splitting. Okay. Or C4.5, they use gain ratio. Okay, and then split info increase if number of split increase. Okay, so they use like this. In C4.5, they also consider if the splitting number of splittings is higher, okay, increase. So the split info is also if split info increase, if number of split increase. So it have the gain ratio and split info. So yeah, the gain information, this is the original gain. Only use gain split, but they also use split info like this. So if there are too many splitting, for example, like this, too many, yeah, from one attribute, gain ratio will be lower. So it will not be chosen. Why? Because if there are so many splitting like this, it will not be efficient. Yeah, okay. So they try to balance number of splitting like this with the gain. Okay. Okay. And yeah, this is the example how to calculate the split info. Okay, like this. Yeah. Okay. And we also can use classification error to replace Gini, but still the same idea. Yeah. Okay, this is if you want to use classification error. Okay, this is the formula 1 minus maximum I probability of I. For example, like this, we have PC1 is 1 over 6. Probability for class 2 is 5 over 6. So between of 5 over 6 and 5 over 6, which one is the maximum one? Which is this one. So 1 minus 5 over 6, like this. Okay. Okay, so I will continue, or you have any question first
So this is
before I
still
continue?
the decision tree only, right? There are many more
Yeah,
methods.
still. Yeah, yeah.
It is just, wow. By the way, yeah, okay. But Dr. Farah, later on, because there are how many? Five, right, for the supervised methods that you mentioned.
How many what?
How many supervised methods you mentioned before? Five, right? I think I remember. There was.
Supervise, we have classification. Uh, and then
So
for
yeah, I mean decision
mhm.
tree and then like blah blah blah. I mean
Oh,
there, yeah. This is still one,
at
right?
the
Yeah, at the
yeah, this is
beginning.
still one.
This is
You
still
mean
one,
this
right?
one?
But
This is
oh, okay, okay. But anyway, for yeah, okay, for predicting like this one, they we can compare several different techniques and then like yeah that one decision tree, neural network, rule based method,
mhm,
memory based
mhm.
reasoning, support vector. So
Yeah.
this okay, so these five we actually can we need to compare something like that, like is it, or using one,
Yes.
or using one is actually already good, I don't know. I mean
Okay. If it depend on our purpose. If you want to evaluate some algorithms, is very required to compare the one algorithm with other algorithms. If the purpose, if you want to evaluate the algorithm, but if you only want to use them to uh, implement in some case, yeah, you can use one or two is okay.
oh, okay, so I think for my case it's going to be the comparing the the algorithm in the okay, so we can anyway, yeah, okay.
Yeah. Okay. Now, to continue Dr. Yogi questions, we can use this. We can how to evaluate the performance of the classifier. Okay. At least there are four ways to evaluate the performance, the result of the classifier. We have hold out, random subsampling, cross validation, or bootstrap. Hold out. Hold out, it means that if we have numbers of data in hand, we will split the data into training set and testing set. This is what Dr. Yogi asking. How many how many percent of the data we use as the training set? How many of them is testing set?
Yes, 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 yes.
Okay. So my answer usually we can combine this with sampling technique. So let's say training, this is the we can imagine that using analogy, this is the population, this is the sample. Okay, so if we think that number of the uh, data in training set is enough to represent the population, then is enough. Uh, for example, we use 90% and as the training, and we use 10% as the testing. However, the pattern of the data in training set, it this 90% data, it doesn't represent uh, this 10% data. For example, this is the, let's say they have 10% very different pattern than 90%. So it will not be enough. Okay, but if maybe I can give you the color, maybe this is blue, 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 blue. Okay, but the rest three maybe red, red, red. Okay, so then we use 90%, the blue one, all is the training set, and the testing set is the red one, these three. It will not be good. Compare if I only use only 80% here and 20% here, but in this 80% I have blue and red. This one also I have blue and red. Then second one will be better than the first one. Okay, so the idea is we have to, no matter how many sample for the training set that we have, those training set, those data in training set should represent all patterns of the data.
Okay, so the adjustment is you made a little bit like human judgment in here, right?
Yeah, yeah.
Okay, so yeah.
Usually you also can combine with like in statistic descriptive, Dr. Yogi. For
Oh yes,
example, we
yes,
have
yes, yes.
many attributes, and then we can use like a stratified random sampling, for example. Okay, so this is a training set. The idea is how to do sampling from this population.
But Dr. Farah,
Yeah.
Dr. Farah,
Yeah.
how would you know? How would you know which one would be put in the training set and which one would be put in the testing set?
Okay. One practical example, for example, before we do this, we use statistic descriptive. Let's say we for attribute X, the predictor, we have like the histogram first. For example, we see blue and red. So we have, for example, like this number of blue one and this number of the red one, for example. Okay, so from this data, from this information, the statistic descriptive, we know from this X, there are two different values, and this is the example. For example, this is the value. So maybe I will take 80% of X, which has the blue value, and the red value is also 80%. Okay, so maybe this is training, this is the training, 80%, and also this is the training, and then this is the testing, and testing.
Okay, so it looks like a politician's, you know, a little bit just in a bit.
Oh, yeah.
Yeah, right. I mean, it's like a politician's a little bit at this one.
But Dr. Farah, you'd be the one to indicate 80 and 20%, right? Oh, okay. So if it's not good, we could change like 70-30.
Yeah, right.
Yeah. No, or even like kick out the data.
So 80, 70, 90, it's depend on us.
Okay, got it.
Okay. But maybe later there is okay after this. Okay, so hold out methods, it just do one-time evaluation. So after we separate into training and testing, and then we develop the data, develop the model, the tree, using training set. Okay, and after that, we have the tree already, and we calculate, we predict the class of the testing set. And then we compare all of them. This one, we will have the training error. This one, we also compare the Y predicted and Y actual. From this, we can have training error. Okay. From this, we also can get testing error. Okay, because we also compare the predicted versus actual. Okay, if if we think the training and testing error or accuracy, okay, are acceptable, for example, okay, the error rate here may be 5%, this one may be 7%, so we think it's enough for us, it's quite accurate, then we can use this data or this model to predict the real future data. Why we don't use 100% data to develop the model and directly predict the new data? Because for if you do 100% for training set, we cannot evaluate how the model behavior to predict the real data. Okay, because the real data we don't have the real value here, we don't know, right? So we don't know exactly how accurate is the prediction. Okay, but if we do like this training and testing, we can say that okay, the model can represent the data. For example, this one 90%, 95% of the data because the training error is 5%. Okay, and if we use this model to calculate the accuracy, to predict the new data, we can have around 7% error, for example. So if we apply this model, this tree, to the new data, after we get the value, for example, the class is yes. But here we can say, the class is yes, but maybe this yes with respect to the the error rate around 7%. So this is not 100% correct because this is prediction, sorry. Okay, the first data for the new data, the class according to the tree is yes. But don't forget, we have around 7% error. Okay, yeah, so this why we have the hold out method. Okay, yeah, so we testing set is to evaluate how robust our model is. Okay. Then we have cross validation. So cross validation is the improvement of the holdout periods. In holdout period, we only divide the data into training and testing, and then do one time to calculate training error and testing error, and then we continue to the new one, to new data. I mean, for cross validation, we also divided the data into training and testing, but all of the data, each instance in the data, have a probability to be chosen as both training or testing. Okay, so for example, like this, in our case, in holdout method, so for example, like this data, and this data only belongs to testing set. Okay, and the rest data belong to training set. But if we use cross validation, each of them will have its turn to be the testing set. So how to do it? Okay, for example, if we set into 5-fold cross validation, usually they have k cross validation, k-fold cross validation. So k is the number of the subs of the number of group. Okay, so for example, we use 5-fold cross validation. It means that our data divided into 5 group. So for example, this is group 1, group 2, 3, 4, and 5. Okay, first, and then what we do is we do hold out method 5 times because we have 5-fold cross validation. So we do hold out method 5 times. For the first hold out, let's see, class 1, 2, 3, 4 belongs to training set, and group 5, data in group 5 belong to the testing set. Okay, and then we develop the model. Second hole out, we change. Now, class 4, this is class 4, belong to the testing set. Group 4 belong to testing set. Group 1, 2, 3, and 5 belong to the testing set. Okay, so the first hole out, 1, 2, 3, 4 belong to training, 5 belongs to testing. Second hole out, 1, 2, 3, 5 belong to training, 4 belong to testing. The third hole out will be 1, 2, what else? 4, 5 belong to training.
Wait, I think she's not here. Artin Ong, can you hear me? Artin Ong, is Dr. Farah here?
Halo, sorry.
Welcome back.
Sorry, my internet suddenly disconnect. Okay. So I don't know until which part. Okay, so cross-validation, all data will have changed to become the training and testing. Yeah, so here we use them like this. Okay, so all of them becomes training, all of them become testing one by one. So in this way, we can make sure that all the data pattern can be captured in the cross validation. Okay, so we can test how robust is our model using different ways of hole out. Okay. Okay, so what we do is, of course, if we want to do data classification, first don't forget to do data preprocessing. For example, if we want to avoid using continuous attributes, a continuous attribute for classification, especially decision tree, it takes a longer computation, so we use discretization, for example. Okay, and then we do cross validation to analyze training and testing error. Okay, if the training and testing error is acceptable, then we can continue to predict the new data. If it is not acceptable, we have to check again. For example, if our data is enough or not. Maybe our data is not enough. So the training and testing error is quite big, for example. Yeah. Or maybe we have to do for example, randomized in cross validation is not good enough. So the testing data always completely different with the training data, for example. Okay, but or maybe, for example, there is imbalance data set. What is imbalance data set? For example, we have 100 data. From 100, let's say we have two class yes or no, or no. Okay, from 100 data, 95% belongs to yes, only 5 of them belongs to no. Okay, so in this case, it is very difficult to get class no. This call it imbalanced data. Means that the number of data for each class is not balanced. Okay, so in this case, most of the data, most of the model will be yes. The class is always yes, for example. Yeah, because the data is imbalanced. This case usually happen, for example, if we want to apply in, for example, let's say medical data. In medical data, for example, the first class is health one, and the majority class is the health one, and the minority class usually is the 6 people, for example. And for let's say the disease is quite rare disease, so it's very, of course, the data will be imbalanced. Yeah. So if we found this data, for example, we can do downsampling or upsampling. Downsampling means that we reduce data in majority class to make it balance with the minority class, or we duplicate data in minority class, so data in minority and majority uh, relatively the same. Yeah. Okay. So of course, after that, after training and testing is acceptable, we can continue to the new data, and then we can analyze the result. Okay, we still have time. I think I still have few slides. Um, we should be careful with what we call it model overfitting, because actually our model is developed from the record data, from the historical data. But our main goal is actually to forecast or to predict the new data. Yeah. So beside make sure the accuracy of the training set is good, we also have to consider the testing set, or to make sure the model is quite robust for the next data. Okay. So what would help in this one? A good classification model must not only fit the training data well, but also must accurately classify records that have never seen before. Okay, so what we want is they have low both for training and testing error. Overfitting is if the model is too fit or too well for the training data, but it has poor generalization for the testing error. Yeah. So for example, this is the error. Okay. Underfitting means that if the error for both testing and training still quite high, yeah, so it's underfitting. It means that, for example, underfitting, the tree is still have, for example, the tree is not too simple, for example. If the tree is too simple, so it's underfitting, not yet enough to learn. Okay. overfitting if the tree is too focused on training error, but then it's not really general enough. So then the new data or the test data will not be accommodated within the model. Yeah, so like this. The training error is very low, but the testing error is high. Okay, so what we want is in the middle of this. So best fitting. We should stop training the model in this part. Okay, so before the test error is increased. Okay, overfitting can be happen, for example, because of presence of noise. There are too many noise, and lack of representative samples, multiple comparison procedure. For example, splitting or criteria setting. So the tree that we develop, we very focused with the splitting and criteria setting. Make sure that the model or the tree have the most optimal tree, but it is only focused on the training. Yeah, we forget to make it quite general, so it is trade-off. Yeah, make it complex enough, but it's general enough for the new data. Okay. So how to estimate the generalization of the tree? Okay, we can use this. For example, we use the training set or validation set. So we can compare the training and testing. Okay, or we also can use this one using resubstituting estimation. So after a tree is developed, we can simulate using the training set. So this is the training set. I'm sorry again.
It's okay.
Okay, so here incorporating model complexity. So based on one theorem, we have one theorem. They say that if we have more than one models, let's say we have two models, both of them give us the same testing error. Okay, then in this case, we should choose the simple one, the more simple one, simpler one. Why? Because usually the simple model has more flexibility for the new data. What we call it the simple one, for example, this is the mod 3 one. Okay, so many brands. Like this. Okay, from the number of brands, the second one is smaller number of brands, or the second one is more simple than the first one. If both of them have the same testing error, let's say the testing error is 10%, 10% here, so we prefer this one because it's more general than the second one. Uh, the fourth way is we can calculate pessimistic error estimates. This is the equation. Yeah, so we can use this for IE3. Okay. Beside that, we also can do what we call it pre-pruning or post-pruning. Pre-pruning means that early stopping rules. So for example, we make one additional condition. For example, if the brands of the tree, for example, already have, let's say, we set additional condition. For example, maximum depth of the tree is 5. It means that this is 1, 2, 3, 4, 5. Then we cannot, although it's still not, all data here is not in one class, we should stop here because maximum depth is 5. This is for pruning, for example. Okay. Or we do post pruning. It means that let the tree grow to its maximum size. So until all of this, and then we trim in bottom up fashion. So from bottom to up, we start from from the lower one, we trim that. Okay. For trimming, we can replacing a subtree with a new leaf node, which class label is determined from the majority class. So for example, which one to trim? Required. Oh, this one. This one we are going to trim into only one here. Then we see from here, for example, at the end of this, they have, for this they have no, yes, maybe they also have no and yes. For this, maybe number of no is 5, 0. This is 0, 4. This one no, yes. This one 6. This one 0. Okay, but we want to trim this part, so we delete all of this, only this. Okay, but then let's see the total data here. So we have how many number of no is 11, yes is 4. So the class here is the majority, so that's why it becomes no. Yeah, so we trim, cut this cut, and then what is the majority class. Okay. Or we can use the we can replace using the most frequent used branch of the subtree. Yeah. Okay, the easiest way is this one. Yeah, using the majority class. Okay, so after that you can go to the Python, and then this one you can use this library scikit-learn, and they have decision tree classifier. Okay, in this uh, in this library they have many example. They give you example using iris dataset, and they also give you some function to modify, for example, like this maximum dip, or we don't want to use Gini, we use entropy, for example. Yeah, I think for after today you can try to explore this first, and understand what have been teach today. And maybe next week, if you have any question, you can also ask me. Okay. Okay, I think this is for today. Any questions?
Dr. Vera, actually, when we need the decision tree, I mean, like, because there are five, right, that you show to me, and then when we think that is actually a good one for the decision tree, is how can you answer that one?
Okay. Decision tree. If we compare these five, which one? Which one? Okay. Decision tree and rule base are basically quite similar. The result. Neural networks SVM is quite different. Usually when I use decision tree, if I really want to know in which attributes that can separate the result. For example, like this. In our case example, we can know, oh, okay, for example, oh, from if the outlook is rainy and then temperature is hot, then it becomes snow. So we have the rules here, Dr. Yogi. So we can understand, oh, if the outlook is overcast, then mostly it will be yes, the class. But if you use neural network base, they will not give you this information. They will just, oh, okay, this is the data, this is the data set, like this is the data set, and then I can give you this belong to no, this belong to yes. But they don't give you information like what happened with the outlook, what happened with the temperature, what happened to humidity and windy. They just give you this data belong to yes, this data belong to no. Okay. Because why? Because this algorithm, neural network based, basically it is they call it black box. We don't know what is inside. We just get the result. This based on mathematics. So this will be like a vector or attribute, just like in the PCA last week. But if you need the information, oh, I want to know, I want really know, like what correlation between each attributes into the class, then better to use decision tree or rule based method.
Okay, so perhaps I can build that by experience, but but I have to know all the five first, and then actually that yeah, okay.
Yeah.
For me, it's clear. Dean, Dean Yang,
Okay. Any question, or maybe if you want to question about
Yes.
your
any
research
questions? Any questions
related to
from
decision tree, very
None
welcome.
from me. None from me.
Okay.
Artinong? No more.
Maybe for the lecture today, no.
Okay,
Okay.
so I think uh because I really hope you try to uh do this decision tree. I don't think you need to do calculate manually. Just use the program, yeah, and then maybe you can use any data. Don't forget, for classification, the data should have the class. Try to use sklearn, scikit-learn. Okay, and then later next week you can ask me if you have any question. Okay. Maybe I also would like to ask for next week, because next week next not next week, next 2